Now, if you look back at it, this is your incoming flow. The region or the point at which the flow is first touching the surface is called the leading edge. This is your leading edge. Why we call it as an edge? Because actually it is not 2D like this. You see this one? When we are talking about this point, it is not a point, it is the edge of this. So when the flow touch this is your leading edge. Okay? This is your leading edge. In this point, the thickness of boundary layer is of course 0. Right? This one is of course 0. As you go further from that, you see the boundary layer is growing. You can see it's growing bigger and bigger and bigger. Now the problem for you, not for me, is how to get this. How thick is the boundary layer? So the question is, what is the thickness of the boundary layer at some distance from the leading edge? Because if I give you the question, what is the boundary layer thickness at the leading edge, you should be able to answer it quickly. 0. Right? But at some distance from the leading edge, it will have some thickness. So how to calculate the thickness? That is the question. That is the problem that you need to solve. Okay? Before we proceed, so what we have learned now from here is, you know what is potential flow? You know potential flow? It's your incoming flow, undisturbed flow. Why we are talking this one is undisturbed flow? Because you take the part that is not affected by any surface. Okay? You have the boundary layer. This is your boundary layer. Edge of the boundary layer. Right? This is your boundary layer. This one is the edge of the boundary layer. And then you have the boundary layer thickness and you have the leading edge. So remember that. We will use that again and again. Okay. So let's open another one. When the flow first touch it, okay, it will start to develop a boundary layer. Initially, it will be laminar. Okay, when you first meet your friend, you are in a good term, right? No issue, no argument, everything just nice. Or when you first meet your lecturer, because you are so afraid, you are laminar. You are very obedient, or not saying anything. You listen to every single thing that lecturer said to you, right? In the middle of the semester, you start to argue. You are not happy with the quiz, you are not happy with the assignment, you are not happy with how the lecturer teach you. Then you start to have the grudge, turbulence, transition from a very obedient student into the rebellion student. Right? At the end of the semester, you cannot stand it anymore. You become more rebellious. You do not want to come to the class. You go to the toilet every time you have a class. Something like that happen. Okay, you do not come to the test. You do not come to the lab. Then all those turbulence will occur. Because at that time, your lecturer will start to sending you the love letter together with the love letter from the registry. Right? Then all those arguments will occur. Same with this. You will start with a smooth laminar. Okay? At some distance from the leading edge, you will start to have a transition. Transition, then you will have low turbulence, then high turbulence. Okay? So from nice curve, you get a lot of random movement. Okay? So you can see here, you start with the laminar boundary layer, transition, and then turbulence. If you want to split the turbulence, it can be split into two later on. Okay, so this is what will happen. When you have a laminar flow, it will be like a, what do you call it? Layer cake or cake layer? You know those? Kue lapis. Right? Yeah, it looks like that, exactly. So the flow will be like that, like the cake layer cake. Okay, everything is just nice. At some region, you will start to have this friendship problem, right? You take your boyfriend, you take her boyfriend, then there's something happened there, or you are gossiping each other because you know more about your friend, right? Then this is all those turbulency occur. Okay. So you can see here, if we are looking at the thickness of the boundary layer, at the laminar flow, it will be small in the laminar region. Then it grows bigger and then bigger and bigger. Okay. So we start with laminar, then following with transition, turbulent, and high turbulence. Now the problem is, when you want to characterize something, you need to have some quantity, right, to characterize it. When you want to say someone is rich, you know the parameters will be money. At the moment, yes, money, right? But when you have an earthquake like the one in Palu, you know you cannot buy anything. You want to buy aircraft, there is no airport. What will you do with the aircraft? Right? You can buy a diamond, but you cannot eat the diamond. So you need to find a characteristic or parameters that quantify. In this case, how do you quantify from laminar to turbulence? Usually what will you use to quantify from laminar to turbulence? Reynolds number. Will it be the same for these cases? What do you think? You have a flow over a flat plate, right? Then the flow changing from laminar into turbulent. What is the parameter that characterize? Oh, I know this flow is laminar. I know this flow is turbulent. How do you know your friend is good or bad? Behavior, right? How do you know your lecture is good or bad? You know, student will say, if this lecture gives me A, he's good. If this lecture gives me F, it's bad. Doesn't matter what. So that is characteristic. You quantify it, right? So the same goes for this one. How do you quantify it? Now, before answering it, let's take a look at what happened, right, in the flow over a flat plate. Okay? So if you look at this flow, you know the parameter that characterize this boundary layer are, of course, the density of the fluid. When you have water moving over a plate, compare it with the oil, you will see it will be different, right? The thickness of this boundary layer will be changing. Or if you compare the cooking oil with water, which has roughly about the same density, the thickness also different, which means viscosity will play a part. Okay? When you have flow moving slowly and when you have flow moving fast, of course the thickness will be different, right? Now the last one is, if you are taking the boundary layer at the leading edge, you know it is 0, but let's say 1 meter from the leading edge, it will not be 0. When it is 2 meters from the leading edge, will it be the same with the one at 1 meter? No, which means your length scale is also important. So now you have density, viscosity, velocity, and x. What kind of parameters that all have all those things? What is the definition of Reynolds number? Rho phi d over mu. Now the problem, you do not have d. What will you do? You replace it with that. So for the boundary layer concept, the Reynolds number is not using D, but it will use X. And the U is the potential flow velocity, which means it is the flow that is undisturbed by the surface. This is the original flow coming through.